Hey guys, so we're starting topic 6, day 1. What is a system of linear equations in two variables? The learning goal today is basically going to define what a system of linear equations is and how they work. So one pencil and one marker cost $1.50. Two pencils and one marker cost $2. What are the cost of one pencil and the cost of one marker? So if you see here in the visual, we're letting P equal our pencil, M equal the marker, and that equals 150. Well, a second equation would be, what if you have two pencils plus one marker? That gives you $2. So a system of linear equations is two or more linear equations with the same two variables that are solved simultaneously. So simultaneously just means they're solved in sync. So I want you all to put this in your Cornell notes. This should be your first vocabulary word, a system of linear equations, and then write the definition. The solution of a system of linear equations is an ordered pair x and y that is a solution of every equation in the system. So this vocabulary word, the solution of systems of linear equations, needs to also go in your Cornell notes. So this should be the second one in your Cornell notes. You need to write everything. So the solution of a system is 0.5 and 1. The values for the variables p and m that makes both equations true. So if you notice here, p represents your 0.5, m represents your 1. Substitute those values into the equations that they're given here, and then you'll see if both of those equal on both sides. If they do, then that means that it is a solution. If it does not, that means that those ordered pairs are not a solution. Your third vocabulary word that goes in your Cornell notes. The solution of a system of linear equations is the point of intersection of the graph of the line defined by the equation. So you're going to write the solution of system of linear equations again, but also you're going to mention in parentheses that it's a graph. So I want you to put graphs next to it in parentheses. And that just simply means wherever the graphs intersect, that is the solution. So now we've done a lot of vocab. Let's talk about and how we can apply it. To determine whether each of the following represents a system of linear equations. Well, remember, a system of linear equations are two different equations. So if we look at our first one is not two linear equations, it's just one expression. So nope. If we look at the next one down below it, this is classified as two linear systems. Well, it has an equal sign, and it also has two different equations. The third one would be no, because it's only one equation. This one up here would be yes, because it has two equations. The next one would be no. The next one would be yes, again it has two equations, and the last one would be no. So I want you guys to try this one. Which of the following represents a system of linear equations? Try this in your OneNote and see if you get it. Is 2, 4 a solution of each system of equations? Explain your reasoning. So for part A and part B, we're given two equations, and they want to know, is the ordered pair 2, 4 a solution to this? So this simply just means let x equal 2, and then let y equal 4. So for part A, let's look at part A first. So we're going to number these. So if I number 1, number 2. So if I do the first one, which says y equals 2x, remember we're going to let y equal 4. And we're going to let x equal 2. We're going to put some parentheses around it. So we can bring down the left side. Well, we know 2 times 4 is 4. So yes, in fact, this is a solution. What if we try the second one? The second equation says y equals 6x minus 8. And then let's say we have y is 4, equals 6. Our x value is 2, minus 8. So we have 4 on the left side. 6 times 2 is 12 minus 8. 4 does in fact equal 4. So yes, that is a solution. Let's look at B. If we do B, 1 and 2, I'll do those in different colors. So remember, B for 1 says x minus y equals negative 1. We let x equal 2 minus my y value, which we let equal 4, and that needs to equal negative 1. Well, 2 minus 4 is negative 2, and that does not equal negative 1. So therefore, no, it's not a solution to that equation. What about 2? 2 says 2x minus y equals 1. So let's let x equal 2. So we have 2 times 2 minus our y, which is 4, equals 1. 2 times 2 is 4, minus 4 equals 1. 4 minus 4 is 0, and 0 does not equal 1, so no, that is not a solution. Try this one in your OneNote or on paper and see if you can get it. Wildlife biologists studied the weight of 2 alligators over a period of 12 months. The initial weight and growth rate of each alligator are shown in the table. Write a system of equations the biologists can use to compare the weights of the alligator. Well, let's look at each part of this information. They want us to actually write an equation where they can compare the weight of those alligators. So when we think about this, we have, let's say we let W equal the weight, and then let's let T equal our rate, or we can say our time. So over time. So let's look at alligator 1. The information that goes with alligator 1. So our initial, we have weight equals, that's our initial weight. We don't know how that starts. So initial weight is going to equal 4 pounds plus my rate of growth that I have, which is 1.5 per month. Remember those vocabulary words we talked about last time. Per month means to multiply. So per month, so 1.5 times our time. So that's how much it changes over the month's time. So this represents the equation of the first alligator. Well, let's look at the second alligator. So we'll do that in red. So alligator 2 for alligator 2, let's look at it. Well, we want to compare the weight. So weight equals the weight of the alligator at the beginning. So their initial starting weight plus their rate of growth per month. So the rate of growth was 1 per month, means we have to multiply it by T. So over time, this alligator grows 1 pound each month. So when we're looking for what is the system of equations, our system of equations would be simply the 2 equations for the alligator. So W equals 4 plus 1.5T, and W equals 6 plus 1T. Alright, so I know that was a lot of work. Let's see if you can try this one on your own and see what you get. So this is the answer I got for the last problem for you to try it. If you have any questions with this problem or any of the problems we did today, please come in with questions tomorrow. Thanks, guys. See ya.